Hello students, this is a Vernier calipers. By using this instrument, we can measure the length of an object. Okay, so this is the basic structure or basic diagram of a Vernier calipers. Now, just try to understand. We want to measure an object. So when you want to measure an object, so what type of instrument you are going to use? Definitely, you are going to use a normal scale. This is a scale, right? Okay, this is 1 centimeter. This is 2 centimeter, this is 3 centimeter, and this is 4 centimeter. So this is a scale where the reading is given, that is 1 centimeter, 2 centimeter, 3 centimeter, and 4 centimeter, right? So to measure an object, to measure the length of an object, basically we use normal scale. Okay, clear? Now I will tell you what is the least count. Least count, when I'm going to tell you least count, what is least count? The smallest measurement which can be made. If you check out the scale, how many number of division there in between 0 to 1 centimeter? In between 0 to 1 centimeter, there is a 10 division. So what can we say? 10 division equals to 1 centimeter. So that means 1 division equals to 1 by 10 centimeter, right? So 1 division will be 1 by 10 centimeter, that means 0.1 centimeter. That is called least count. What is this? This is the least count of the scale. And as I told you before, what is least count? Least count is the smallest measurement which can be made. So what is least count? Least count is the smallest measurement which can be made. Okay. So in this diagram, the smallest measurement which can be made equals to 0.1 centimeter. Okay. I hope it is clear to all of you. Now I'm moving to the next slide. Look, here I will tell you why we are going to use screw gauge instead of normal scale. So if I tell you that look, this is a normal scale, okay, there is an object. What is the length of the object? The length of the object is 1.24 centimeter. Is that clear to all of you? The length of the object is 1.24 centimeter. Okay, but the thing is that, can we measure the length of the object? Look, if I ask you to measure the length of the object, so look, this length of this point, okay, length of this point, because this, if I say this end is A and if I say this end is B, so the B is lying between 1.2 centimeter to 1.3 centimeter, right? This B point is lying in between 1.2 centimeter and 1.3 centimeter. Clear? But what is the exact length of the object? The exact length of the object is 1.24 centimeter. So it is very difficult to find out the length of the object, because you cannot consider 1.2 and you also cannot consider 1.3. So this is very difficult to find out the measure of the object. But somehow, if we find more division, so accurately or precisely you can measure the length of the object. Clear? So by normal scale, sometime we cannot measure the length of the object. Clear? So ordinary scale or normal scale cannot measure precisely. So that's why we are introducing a Vernier scale or Vernier calipers. In a Vernier calipers, we can measure that there is a division up to 1000. Clear? Clear? As in the ordinary scale, we can, in the ordinary scale, the least count is 0.1 centimeter. But in a Vernier scale, in the Vernier scale, the least count, in the Vernier scale, the least count is 1 up to 1 by 1000 centimeter or millimeter. Okay, got it? So by using vernier calipers, we can easily find out the length of the object. But it is very difficult. Sometimes it is very difficult, clear, to find out the length of the object by using an ordinary scale. Because in the ordinary scale, there will be some error. Okay, got it? Next. So what is the uses of the vernier calipers? By using the vernier calipers, we can measure the length of the object, the breadth of the object, the height of the object. Okay, we can also measure the diameter of the object. Clear? Okay, so these are the uses of a vernier calipers. Clear? I hope it is clear to all of you. So what is the uses of the vernier calipers? By using the vernier calipers, we can find out the length of the object, the breadth of the object, the height of the object. Okay, and also we can find out the diameter of spherical or cylindrical body. Clear? Now I will tell you what is the least count. In the vernier calipers, if you check out a vernier calipers, if you check out a vernier calipers, there will be a main scale. There will be a main scale. Just try to understand, this is very important. There will be a main scale and there will be a vernier scale. Okay, vernier scale. This is the division. This is the first division. Okay, this is the smallest division. That is the least count of the vernier main scale, and this is the least count of the vernier scale. Clear? Suppose the least count of the main scale is A. As I told you, what is least count? The smallest measurement which can be made. And the least count of the vernier scale is B. The least count of the main scale is A and the least count of the vernier scale is B. Now my question is, what will be the smallest measurement which can be made by using this vernier scale? My question is, what is the smallest measurement which can be made by using this vernier scale? Clear? Just try to understand. This is the least count of the main scale and this is the least count of the vernier scale. As I told you, what is the least count of the main scale is A. And what is the least count of the vernier main scale is A and the least count of the vernier scale is B. So what is the smallest measurement which can be made? A or B? Not A and also not B. Okay, we can measure this length, this one, this length we can measure. This is the smallest length or this is the least count. Okay, look, if I say this is C, so what will be C? C will be A minus B. I hope it is clear. Just try to understand. The smallest division or the least count of the main scale is A. The least count of the main scale is A, right? And the least count of the vernier scale is B. Clear? So which one is the smallest? Not A, not B. In between A and B, this one is the smallest length. Shortest length, this one. And the shortest length is called least count. So what will be the least count? Least count C will be A minus B. Clear? Okay. So when you are trying to find out the least count, definitely you have to remember that what will be the formula for least count? 1 main scale division minus 1 vernier scale division. Because this is the 1 main scale division, this is the least count. That means this is the 1 main scale division minus 1 vernier scale division. Okay. Is that clear to all of you? I hope, students, it is very clear to all of you. Clear? So when you are trying to find out the least count, you have to know one thing. You just have to know one thing. The least count is the smallest division. And here what will be the smallest division? A is not the smallest division, B is not the smallest division, but the minus of A minus B. Okay, the subtraction of A minus B, the subtraction of A minus B, it will give us the least count of this instrument. Clear? So when you are trying to find out the least count, we have to subtract the value between 1 main scale division minus 1 vernier scale division. Is that clear to all of you? 1 main scale division minus 1 vernier scale division. Okay, clear? I'm moving to the next slide. Before that, you have to clear whatever you have learned. Okay, now I will find out the least count of an vernier calipers. Suppose this is the main scale. What is this? This is the main scale. Main scale. And this one is the vernier scale. This one is the vernier scale. Clear? If you check it out, then in the main scale there is a 9 division, and in the there is 9 division, and there is a in the vernier scale there is a 10 division. Okay, instead of taking 9 and 10, let us consider in the main scale there is a m division, m division, and in the vernier scale there is a n division. Okay, so in the main scale there is a m division, in the vernier scale there is a n division, and as I told you in the previous slide, that least count, how can we get the least count? That we need to subtract one main scale division minus one vernier scale division. Is that clear to all of you? I hope it is clear to all of you. So when you are trying to find out the least count, you have to know one thing, that how can you get the value of least count? One main scale division minus one vernier scale division. Okay, clear? So just try to understand. Can I say, look, this n number of main scale, m number of main scale, clear, is coincide with n number of vernier scale? Yes or no? Okay, n number of main scale division is coincide with n number of vernier scale division. So we can say one thing, that n main scale division, that is n main scale division, okay, sorry, n vernier scale division, just try to understand, n vernier scale division is equivalent to m main scale division. Yes or no? So we can say n main scale, n vernier scale division, just try to understand here, because main scale and vernier scale are coincide with each other. So just we can say one thing, that n vernier scale division is equivalent to m main scale division. So what can we say? One vernier scale division must be equivalent to m by n main scale division. Yes or no? It will be small n. Okay, clear? So one vernier scale division must be equivalent to m by n main scale division. Clear? Yes or no? Just try to understand. Just try to understand. Just try to understand. Okay. N vernier scale division is equivalent to m main scale division. Main scale division. So one vernier scale division must be equivalent to m by n main scale division, that we have written here. That we have written here. Just try to understand. So one vernier scale division is equivalent to m by n main scale division. It is very important. Now guys, what will be the least count? As I told you, the formula for least count is one main scale division minus one vernier scale division. Clear? The formula for least count is one main scale division minus one vernier scale division. So that will be equals to one main scale division minus one vernier scale division. Just try to understand, one vernier scale division is equivalent to m by n main scale division. So I will write here m by n main scale division. So what will be the least count? Look, main scale division will be the common part. So main scale division into 1 minus m by n. That is the important formula to find out the least count of a vernier calipers. Is that clear to all of you? This is the formula to find out the least count of vernier calipers. Okay guys, I hope it is clear to all of you. Now in the ordinary vernier calipers, if I take a ordinary vernier calipers, that there will be 9 main scale division. This is main scale division, and this is vernier scale division. Okay, here I'm talking about an ordinary vernier calipers. So in an ordinary vernier calipers, there will be, okay, 9 main scale division will be equivalent to 10 vernier scale division. So if I say 9 vernier scale division will be equivalent to 10 vernier scale division will be equals to 9 main scale division. Clear? And we know what is the formula to find out the least count. 1 main scale division minus 1 Vernier scale division. Clear? And after doing this, we know the formula for least count is MSD is the common part with 1 minus m by n. Okay, clear? 1 minus m by n. Okay, what is MSD? Main scale division. So what is the main scale division? Main scale division 1, okay, 10 centimeter. Just try to understand. Okay, 10 division, sorry, 10 division equals to 1 centimeter. So 1 division will be 1 by 10 centimeter. That is 0.1 centimeter. 1 division of main scale. So what I am going to tell you, in the main scale there is a 0 to 10 division. Okay, in 0 to 10 division, that is 1 centimeter. So 1 centimeter means 10 division. So 1 division means 1 1 by 10 centimeter, that is 0.1 centimeter. Okay, so 1 main scale division, 1 main scale division equals to 0.1 centimeter. So we have to put the value here, that is 0.1 centimeter with a bracket 1 minus m by n. So guys, what is m here? Definitely 9. What is n here? N is the Vernier scale division. And students, what is the Vernier scale division? The Vernier scale division is 10 and the main scale division m is 9. Okay, the m number of main scale division coincide with n number of Vernier scale division. Clear? So which point they are coinciding? 9 main scale division coincide with 10 Vernier scale division. 9 main scale division coincide with 10 Vernier scale division. So just put the value. If I put the value, our answer will be 0.01 centimeter. So for an ordinary scale, the least count is 0.01 centimeter. Okay. Next, this diagram, from this diagram, I can say how can we find out the length or the diameter of an object. There is a 2 point, or you can say two end of a vernier calipers. One end I say A and another end I will say B. Okay. Now in between A and B, we are keeping an object. Clear? In this object, we have to find out the diameter. Okay. So there is a main scale. Just try to understand. There is a main scale and there is also vernier scale. Clear? So by using the reading or by using the formula, we can easily find out what will be the diameter of the object. Okay. So in between the two end, we have to keep an object to find the diameter or the length of the object. Okay. Next, now I will show you how can we keep an object. Clear? There is a look, there is a main scale. This is the main scale and this is the vernier scale. This is the vernier scale, right? Okay. Clear? So by using this main scale and by using this vernier scale, we can find out that what will be the length of the rod. Okay, just try to understand. There is a main scale and there is a vernier scale. Clear? There is a main scale and there is a vernier scale. Okay, yes or no? And in between this two end A and B, we are keeping an object. Clear? We are keeping an object. Okay, and there will be a main scale reading and there will be a vernier scale reading, and by using this we can easily find out what will be the length of the rod. Okay guys. Next is what will be the reading. Next is what will be the total reading. Now I am going to tell you what will be the total reading. How can we find out the total reading? Total reading means main scale reading plus Vernier scale reading. When I am going to tell you that what is the total reading means main scale reading plus Vernier scale reading. Okay, clear? You can easily find out what will be the main scale reading. How can we get the main scale reading? Clear? I will show you how can we find out the main scale reading. Got it? But to find out the Vernier scale reading of the Vernier scale. Clear? So what we have to do? We need to take the least count and the coinciding division of Vernier scale with main scale. Got it? That means if this is the main scale, okay, and there is a different division, these are the division of the main scale. Clear? And suppose this is the Vernier scale. Okay, these are the division of the Vernier scale. So if this main scale and if this Vernier scale are coincide with each other at a point, if the main scale and the Vernier scale are coincide at a point with each other, right, then we can find out, or then we will take the reading. Clear? Suppose this 1 2 3 4 5 6 7. Okay, clear? At what division this Vernier scale coincide with the main scale? 7. So I will take the reading is 7 into least count. Least count may be anything, right, depending on the instrument. Clear? So reading means reading of the main scale and reading of the Vernier scale. Clear? Okay, suppose this is 0. If I draw a precise diagram, you will understand clearly. Just wait, I will draw the diagram here. Okay, suppose this is our main scale and this is our Vernier scale. Okay, in between this there is an object. This is the object. Object is fixed here. Okay, clear? This is the 0 of the Vernier scale. This is the 0 of the Vernier scale. Clear? Okay, and just try to understand. This is the main scale reading. This is main scale. These are the divisions. These are the divisions of the main scale. Okay, and these are the division of the Vernier scale. I will draw here. Clear? Suppose this is x centimeter. Okay, just before 0. Clear? Because there will be up to this there is a x centimeter. This distance x centimeter. So I will take x plus. Now I will take the Vernier scale reading. So I will take how to get the Vernier scale reading. We need to get the least count into the coinciding point between the main scale and the Vernier scale. Suppose this point they coincide. Suppose at this reading, okay, this division of the Vernier scale coincide with the main scale. Clear? So what is the division? 1 2 3 4. So I will multiply with 4. Yes or no? Now I will talk about zero error. What is zero error? Zero error arises due to the incorrect gradation of the scales of the Vernier calipers is called zero error. That means if the instrument is not correct, okay, if there is an instrumental error, that is called zero error. And what is no zero error? If there is a no instrumental error, that is called no zero error. Okay guys, so if there is a no instrumental error, that is called no zero error. Now I will tell you that what is no zero error, because zero error if there is a zero error, there is a two types of zero error. Okay, first of all, I will tell you no zero error. This is not the type. What is no zero error? Look, zero of the main scale, this is the main scale. What is this? This is the main scale, and below line is the vernier scale. Clear? This line is the vernier scale. So just try to understand, the zero of the main scale is coincide with the zero of the vernier scale. Clear? Before measuring the before measuring the length, radius of any object, okay, you want to check there is a error or not. How to check it? If the zero of the main scale is coincide with zero of the vernier scale, that is called no zero error. And next is, what is positive error? Positive error is the zero of the vernier scale. Just try to understand, this is the vernier scale, zero of the vernier scale, and this is the zero of the main scale. If the zero of the vernier scale, okay, zero of the vernier scale is ahead of, or if zero of the vernier scale is after the zero of the main scale, that is called positive zero error. Okay, is that clear to all of you? I will repeat it again. This zero of the vernier scale, this is the zero of the vernier scale, and this is the zero of the main scale. The zero of the vernier scale is just after, not before, sorry, just after zero of the main scale. That is called positive error. And guys, what is negative error? Zero of the vernier scale is before the zero of the main scale. Zero of the vernier scale is before zero of the main scale. That is called negative error. Okay, I hope it is clear to all of you. So what is this? Zero of the main scale, if zero of the main scale is coincide with zero of the vernier scale, zero of the main scale is coincide with zero of the vernier scale, that is called no zero error. And what is positive error? Positive error is zero of the vernier scale, okay, is after, clear, is after zero of the main scale. Okay, they are not coinciding, but zero of the vernier scale is after zero of the main scale, that is called positive error. And what is negative error? Zero of the vernier scale is before zero of the main scale, that is called negative error. Okay, next. So if I tell you again the positive zero error, what is positive zero error? That positive zero error is zero of the vernier scale after, it will be after zero of the main scale. Clear? And how to calculate the positive zero error? When you want to find out the zero error, what is the error here? Okay, look, the fifth division of the vernier scale, this fifth division of the vernier scale is coincide with main scale. The fifth division of the vernier scale is coincide with the main scale. 1 2 3 4 5. Is that clear to all of you? The fifth division of the vernier scale is coincide with the main scale. Okay, so what will be the zero error? Zero error will be plus, what is the division here? Fifth division, so fifth into least count. And what will be the true reading? The true reading will be observed reading. Okay, the true reading will be observed reading of the instrument. Clear? When you are finding the length or whatever, observed reading minus of zero error. Observed reading minus of zero error. Clear? Observed reading means the reading, okay, clear? The reading whatever you got by the vernier or the slide calipers minus the zero error, whatever error is there. This is before, this is before measuring, this is before. How to get the zero error? Before measuring or before measure, okay, and this is after measuring the length of the object. Clear? This is called positive zero error. Okay, so how to get the positive zero error? The coinciding point, and that is fifth division, the coinciding point, that is fifth division into least count. That will give you the zero error. Okay. Now negative zero error. What is negative zero error? As I told you, what is negative zero error? The zero of the Vernier scale before, it will be before zero of the main scale, that is called negative zero error. Okay. How to get the how to find out the negative zero error? Look, their fifth point of the Vernier scale, the fifth point of the Vernier scale is coincide with the main scale. So what will be the zero error? Minus 5 into the least count. The formula will be minus 5 because the formula is minus 5 into least count. Now what will be the true reading? True reading will be observed reading. Okay, clear, whatever the length or whatever the diameter you have, clear, of the object minus zero error. Okay, minus of minus zero error. That is the formula to find out the negative error. Okay, I hope it is clear to all of you. Clear? Now, some important numerical on Vernier calipers. Now I am going to tell you, or we are going to solve some important numerical on Vernier calipers. What is the first numerical? Let's see. In Vernier calipers, the main scale is marked in millimeter and 20 Vernier scale divisions are equals to 16 main scale division. We have to calculate the least count. Okay. So guys, how can we find out the least count? As I told you before, the formula for least count is main scale division into 1 minus m by n. What is m here? What is the coinciding point? Okay, at which point they coincide, that is m is the main scale division and n is the Vernier scale division. Okay, clear? So just try to understand. In Vernier calipers, the main scale is marked in millimeter. So if the main scale is marked in millimeter, so one division will be 1 millimeter. One main scale division will be definitely 1 main scale division will be 1 millimeter into 1 minus m by n. What is m here? Main scale division. The coinciding point 16 main scale division. Okay, so 20 Vernier scale divisions are equals to 16 main scale division. Okay, so 16 main scale division, that means this is m, and 20 Vernier scale division, that means this is n. So it will be 16 by 20. Okay, that will be 1 into, clear, 4 by 20, right? Okay, is that clear to all of you? That will be 0.2 millimeter. Yes or no? What will be the answer? 0.2 millimeter. It will be the answer from this question. I hope it is clear to all of you. Now this is the second question. In a Vernier calipers, 10 Vernier scale division is equivalent to 9 main scale division. So 10 Vernier scale division, that means this is n. 9 main scale division, that means this is m. Okay. And 1 centimeter on main scale is divided into 10 parts. What is the meaning of that? Just try to understand. This is, suppose this is up to this is 1 centimeter. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? So 10 division in main scale is equivalent to 1 centimeter. So 1 division main scale, 1 main scale division equals to 1 by 10 centimeter, right? That means 0.1 centimeter. So 1 main scale division is 0.1 centimeter. Clear? Now you can find out the least count. Okay. Oh, and it is also given the zero of Vernier scale. The zero of Vernier scale. This is the Vernier scale. Draw a main scale and draw a vernier scale. So if this is the vernier scale, this is the main scale. So the zero of the vernier scale, clear? Zero of the vernier scale just ahead of 1.8 centimeter. So this is 1.8 centimeter. And the fourth division of vernier scale is coincide with the main division. So fourth division, okay, clear? The fourth division of the vernier scale, this is the fourth division. So what will be the total reading? So total reading will be, we know that total reading is main scale reading plus vernier scale reading. And what is the main scale reading? Clear? 1.8 centimeter, okay, plus vernier scale reading. But we have to how to get the vernier scale reading? To get the vernier scale reading, you need to know that the formula is least count into, clear, vernier scale coincide with main scale. So at what point the vernier scale coincide? So 1.8 into least count we don't know. At which point they will coincide? They will coincide at fourth point. So just multiply with 4. But what is the least count? As I told you, the formula for least count is 1 main scale division into 1 minus m by n. Okay, so 1 main scale division, that means 0.1 centimeter, and 1 minus m by n. What is m by n here? So guys, just try to understand. M is 9 and n is 10. That means it will be 0.01 centimeter. Clear? So it will be 1.8 plus 0.01 into 4, that will be 1.84 centimeter. So what will be the answer? The answer will be 1.84 centimeter. Which option will be correct here? Option B will be correct in this question. Okay. Next. The next question is, the diameter of a cylinder is measured using a vernier calipers with no zero error. It is found that the zero of the vernier scale lies between 5.10 centimeter and 5.15 centimeter. So at first I will draw the main scale. This is the main scale. Okay, clear? And zero of the vernier scale, suppose this is the zero of the vernier scale, is lying between 5.10, this is 5.10 and this is 5.15. Clear? So just try to understand, if I say this point is A and this point is B, so what is the smallest division of the main scale? 5.10 and this is the 5.15. So if you want to measure, okay, the smallest division of the main scale is 0.05 centimeter. So what is the smallest division of the main scale? 0.05 centimeter. Clear? Okay. So we have to find out the least count. So one main scale division equals to 0.05 centimeters. Just try to understand. In this question, just try to understand. The zero of the vernier scale is lying between 5.10 to 5.15. Clear? So this is the main scale, 5.10 to 5.15. So what is the division? What is the smallest division you can measure? The smallest division you can measure, that is 0.05 centimeter. Okay. I hope it is clear to all of you. So one main scale division is 0.05 centimeter. And what about the vernier scale division? Just try to understand. 50 vernier scale division equals to, just try to understand, 50 division of vernier scale is equivalent to 2.45. It is equivalent to 2.45. So one vernier scale division will be equivalent to 2.45 by 50. That will be 0.049. Okay, yes or no? That will be 0.049. Okay. So one vernier scale division here, one vernier scale division equals to 0.049 centimeter. Okay, got it? So we know what is the formula for least count. To find out the least count, the formula is 1 main scale division minus 1 Vernier scale division. So what is 1 main scale division? That is 0.05. What is 1 Vernier scale division? That is 0.049. Okay, that will be 0.0, clear, 0.1 centimeter. So guys, what is the least count in this question? The least count is 0.001 centimeter. I hope it is clear to all of you. I'm hoping it is clear to all of you. Clear? And what is the question? The 24th division of the Vernier scale is exactly coincide with one of the main scale division. So total reading. So now you have to find out the total reading. So guys, just try to understand what will be the total reading. Okay. Clear? So what will be the total reading? So we know the formula for total reading is main scale reading plus Vernier scale reading. So guys, what is the main scale reading? Okay, you have to know what is main scale reading. Clear? Just before 0, when you are finding the main scale reading, just before 0, what is the main scale reading? What is the reading of the main scale? Clear? Just before 0 of the Vernier scale reading. Before 0 of the Vernier scale reading, this is the Vernier scale 0. 0 of the, just before the 0 of the Vernier scale reading, main scale reading is 5.10. So 5.10 centimeter plus Vernier scale reading. Do you remember what is the formula for Vernier scale reading? Least count into least count. And what is the least count into? Clear? The coinciding point. What is the least count? Least count is 0.001 into, at which point they are coinciding? At 24th division. So 24. Clear? The answer will be in centimeter. Okay. Clear? So what will be the, if I multiply, then what will be the value of this? It will be 5.124 centimeter. Which answer is correct? Option B is correct. Clear? The main thing is that it is not given. The main thing is that, just try to understand. 0, this is 0, right? The 0 of the Vernier scale is in between 5.10 and 5.15. From this one, we can easily get the main scale division. And what is the main scale division? That is 0.05 centimeter. Okay, I hope it is clear to all of you. Clear? Next is, student measured the length of a rod and wrote it is as 3.50 centimeter. Which instrument did he use to measure it? Option A, meter scale. Option B, Vernier scale. Screw gauge, which one? So by using meter scale, it is not possible, right? Clear? So now we have to find out which instrument he used. Okay. So he wrote actual reading, he wrote 3.50 centimeter. Clear? He wrote the actual reading is 3.50 centimeter, right? Okay. Clear? So what will be the least count? By using this, we can find out the least count. How did he get this? What will be the least count? I will say the least count is 0.01 centimeter. How it is possible 0.01 centimeter? How did he get 0? How did he reach 0.01 centimeter? He reached out 0.01 centimeter, na? Okay, look, this is 3.50, na? Clear? How did he get 3.50? That means he got 0. Clear? Just try to understand. 0.01. Okay, sorry, 3.01, 3.02, 3.03, till up to this he got 3.50. Clear? Okay, is that clear to all of you? 0.01, 0.02, 0.03, dot dot dot, up to he got 0.50. So what is the least count? Least count we can say that is 0.01. Okay. So what is the least count? Least count is 0.01. Clear? Now the thing is that which instrument he used. Clear? Because because in normal scale and an ordinary scale, least count is 0.01 is not possible. So we have to find out which scale. Okay, so we have to find out. Just try to understand according to the question what is the given value. In this question, it is said that the Vernier calipers where the 10 division in the Vernier scale match with 9 scale of the main scale. Okay, so I will find out the least count. What is the formula for least count? 1 main scale division into 1 minus m by n. Clear? Okay, 1 minus m by n. What is m here? 9. What is n here? 10. What is 1 main scale division? What is the 1 main scale division, right? Just try to understand. 10 division of 10 division in main scale is 1 centimeter. 10 division is 1 centimeter. 10 divisions in 1 centimeter. In the main scale there is a 10 division in 1 centimeter. So 1 main scale division will be definitely 1 by 10, that is 0.1, right? So 0.1. Clear? Okay, so it will be 0.01. So got it? So which option will be correct here? Option B will be correct. So it is matched with option B. I hope it is clear to all of you. Okay. Now next. In an experiment, the angle are required to measure the using an instrument. In an experiment, the angles are required to measure using an instrument. 29 division of main scale is exactly coincide with 30 division of the Vernier scale. If the smallest division of the main scale is half a degree, then the least count of the instrument. So guys, we can find out the how to get the least count. Just try to understand. In this question it is given that is 30 division of Vernier scale coincide with 29 division of the main scale, right? 30 division of the main scale is coincide with 29 of the Vernier scale. Clear? So therefore, one Vernier scale division will be 29 by 30 main scale division. Clear? Okay, one Vernier scale division will be 29 by 30, right? Therefore, least count, and we know what is the formula for least count. 1 main scale division minus 1 Vernier scale division. Clear? Okay, so we have to put the value of 1 Vernier scale division. What is the value of 1 Vernier scale division? That is 29 by 30. So just put the value 29 by 30. Take the common part, main scale division. So it will be 1 by 30 into main scale division, right? And we know 1 main scale division is 0.5 degree. Clear? 0.5 degree. Yes or no? Yes or no? Clear? So it will be 0.5 degree. Okay, got it. And you have to know one thing, that 0.5 degree, okay, is 0.5 degree is 30 minute. Clear? So this 30 and this 30 will cancel. So what will remain here? 1 minute. So which option will be correct? 1 minute. Clear? In this question, it is already given the 30 division of the main scale, Vernier scale is coincide with 29 division of the main scale. So we can say directly 1 Vernier scale division is 29 by 30 main scale division. So what will be the least count? Least count is 1 main scale division minus 1 Vernier scale division. Clear? Least count will be 1 main scale division minus 1 Vernier scale division. Okay, and we can say what is 1 Vernier scale? That will be 29 by 30 into main scale division. Clear? Now put the value. If I solve it, then it will be 1 by 30 main scale division, and 1 main scale division equals to 0.5 degree, and 0.5 degree 0.5 degree equals to 30 minute. Okay, so just put the value. 30 and 30 will get cancelled. What will remain here? The remaining value will be 1 minute. Okay, now next, a spectrometer gives the following reading when used to measure the angle of prism. Main scale reading is 58.5 degree. Vernier scale reading is 0.9 division. Given that one division of main scale correspond to 0.5 degree. The total division of the Vernier scale is 30 and matched with 29 division of the main scale. The angle of prism of the data. Clear? How to do it? Just try to understand what is the total reading. We know the total reading is main scale reading plus Vernier scale reading into least count. Okay, main scale reading into Vernier scale reading into least count. Clear? What is the main scale reading? It is given the main scale reading is 58.5. And what is the Vernier scale reading? The Vernier scale reading is already given, that is 0.9 division. Clear? Okay. And we have to find out the least count. Guys, what will be the least count? How to get the least count? Just try to understand. Least count is main scale division into 1 minus m by n. And what is the main scale division? Clear? Just try to understand. 1 division of main scale is 0.5 degree. So just write here 0.5 degree. Okay. Into 1 minus m by n. What is m here? M is 29 and n is 30. So that will be 0.5 by 30. Right? That this value. Clear? Now the total reading, what will be the total reading? That is main scale reading plus Vernier scale reading into least count. What is the main scale reading? That is 58.5 degree. Yes or no? And what is the Vernier scale reading? We have to, the Vernier scale reading is 9 division. So 9 into least count. What is the least count? 0.5 degree by 30, right? And we know 0.5 degree is 30 degree. Okay, we have to put 30 degree is, what is the value of 30 degree? Clear? 30 degree is this 30, sorry, this 30 is, clear, 0.5. Okay, so just put the value, you will get 58.65. Okay, clear? Because when you are putting the value na, 0.5 degree equals to, okay, 30 minute. Clear? Got it? So what will be 30 minute? So if I put the value of 30 minute here, if I put the value of 30 minute, right? Clear? So it will be 0.5. So the final answer will be 58.65. Okay, I hope it is clear to all of you. Next, 9 division on the main scale of a Vernier calipers coincide with n plus 1 division of the Vernier scale. Clear? N division of the main scale of a Vernier calipers coincide with n plus 1 division of the Vernier scale. If each division of the main scale is a unit, the least count of the instrument. So here we have to find out the least count. So guys, what is the formula for least count? Main scale division into 1 minus m by n, right? So just try to understand what is the main scale division. Okay, the main scale division is a unit, so we have to write here a into 1 minus m by n. What is m here? Main scale reading. And what is main scale reading? Clear? Just write n division of the main scale. So n division of the main scale coincide with n plus 1. So this is n, this is Vernier scale, and this is main scale, this is m. So it will be n plus 1. Clear? So it will be a by n plus 1, because n and n will get cancelled. So it will be a by n plus 1. The answer will be option D. Okay, clear? I hope it is clear to all of you. Next, the diameter of a steel ball is measured using Vernier calipers which has division 0.1 centimeter on its main scale, and 10 division of its Vernier scale match with 9 division of the main scale. Clear? So 10 division of the main Vernier scale. So Vernier scale it is given na. Clear? So n is given, that is 10, and m is given, that is 9. Okay, clear? 3 such measurement are given. If the error is minus 0.03 centimeter, then the mean corrected diameter, we have to find out the mean corrected diameter. So guys, just try to understand, from this value we can easily find out the least count. What will be the least count? Least count will be, clear, main scale division 1 minus m by n. So what is the main scale division? Just try to understand, main scale division is 0.1 centimeter. So I will write here 0.1 centimeter into 1 minus m by n. What is m here? 9, and n is 10 here. Okay, so it will be 0.01 centimeter, right? Yes or no? Clear? Now the thing is that we have to find out the corrected diameter. So least count we got, that is 0.01 centimeter. Okay, the first reading will be main scale reading, that is 0.5, plus vernier scale division, that is 8, okay, into least count, because when you are finding the total reading is main scale reading plus vernier scale reading into least count, plus error. What is the error? 0.03 centimeter. So just put the error here. Clear? So the value is 0.61 centimeter. And the second thing is that what will be D2 second diameter will be main scale reading plus vernier scale reading, and the second division is 4. In the second, at the second time, at which division, which point they will coincide, the vernier division, the vernier reading is coincide with fourth division, so 4. And the third point, it is coincide with 6. Clear? So after doing this, what will be the mean diameter? The mean diameter will be 0.61, this is the first one, 0.57, that is second one, 0.59, that is third one, by 3. So what will be the final answer? 0.59 will be the final answer. So which option will be correct here? Option B will be correct here in this question. Okay.